Good afternoon, everybody. My name is Cian. I'm a security engineer in the Google office in Zurich.
And my name is Harald Wagener, and I'm also a security engineer in the Google office in Zurich.
So we are going to present this afternoon to you our talk on enterprise architecture beyond the perimeter. Originally, it was intended that Synnott would be my co-speaker, but he excuses himself because he has a family emergency to attend. So that's why Harold happily took over the part of Cian. All right, so what are we going to talk about today?
So quickly walk through the agenda. I make it quick. So first we review the classic parameter model that we want to get rid of. And then we will go into what we think what going beyond the parameter means. We will present you with a architecture blueprint, and along the way give you an overview over some challenges that we met and hopefully overcame. And then for people who want to follow that model, there's some advice and directions, and of course some time for questions.
All right, so this is still also work in progress. So we're also happy to have your feedback. So we are available after the talk outside this room. Feel free to contact us, and we are happy to answer your questions in more detail and go into more specifics if you want. Okay, so let's review the classic perimeter model. So when you look into IT security, like lots of things we have in our IT infrastructure, they resemble things from physical security. And that's more or less moats and castles. So you basically have your precious stuff in your corporate network inside, right? And you build big high walls around it. And you have a few very controlled gates to actually get into the precious corporate network. So basically the idea is we have the good guys and the precious stuff inside, and we want to keep out the bad people. However, this model, when you look at it, it means that you have intrinsic trust into people who are inside a corporate network. So the assumption we sort of set up like maybe 20 years ago is like that only the people inside our network, these are the good ones. And we actually gave quite a lot of high privileged access on those networks.
So in truth, what we have is a crunchy shell and a soft melty core. There are lots of little things that aren't as well guarded as your organization's network. And attackers have figured this out, and they evolved, and they also evolved the ways they attack. They look for the weakest link, which usually is the device that people use to access your network. And these have become highly mobile in the recent years. So you don't have that level of control that the 20-plus-year-old model assumes. Effectively, firewalls don't help, and a lot of other controls that try to be gatekeeping the incoming and outgoing data that rely on a parameter or those strongly guarded gates, they simply don't help, and you have to think about this in a different way. And that different way is
what we're going to talk about now. So we decided to think about the whole security aspect and this model in a different way. And we came up with a program inside of Google which we call Beyond Corp. And the mission statement of this program is as follows. We want to re-architect the corporate services to remove any privilege associated with having a corporate network access, a network address. The effort is pretty big. It spans multiple parts of the organization in Google, from corporate engineering through network teams, and also the security team.
So there are different parts to this vision of Beyond Corp access. And we simply want to completely get rid of the idea that you have a parameter within, you have some kind of elevated trust just because you're on the corporate network. And this touches 3 different points. The first is authentication. So basically, you need to authenticate every kind of access that happens to your corporate services. And you need to have strong authorization controls as well. And these have to work outside the perimeter, that means over the internet. And having untrusted networks as part of the environment you look at also means that you will need to think with encryption everywhere. So encryption moves from being optional and a nice thing to have to being mandatory for every single service that you run under the Beyond Corp model.
The second part of the vision is about user experience. So we want to work, or we want to get into a place where people can work from different networks, meaning they can work in the office from their desktop, but they're not limited to that. They can go to a coffee shop, access the Wi-Fi, and continue their work from there. So the second part of it is in a corporate environment, usually you have a lot of workflows which are not very cloud-based, or let's say they have legacy infrastructure. And we want to move a lot of these workflows into the cloud so that we can make them available through the web.
And another almost side effect, but very important, is that we want to limit access to our services by a policy that we control only. So instead of denying people access because they come from the coffee shop Wi-Fi, we want to deny them access because we know something about their device or their user account, like group memberships, that doesn't allow access. So technical limitations should not exist anymore. As soon as you have some kind of connectivity, you should be able to access what is granted to you.
Okay, so this was a high-level overview of the mission statement and the vision. And we have developed an architecture blueprint to support this model. And there are following ideas behind it. So we want to move the trust from the network level, meaning IP address, up to the device level. And as we are not relying on the IP address anymore, we have to come up with another concept to identify a device. So it's important that we come up with an idea about device identity and represent this identity with a credential a device can use to authenticate against our infrastructure. And the next aspect is that we know about the device. We know that it's a device which is Google controlled or managed, if you like. We want to know its state. So there's a link between the identity and the actual inventory for this identity. And last but not least, we want to implement authorization controls based not just on user-specific things like group membership, but also on the state of the device. And to put it a little bit more clearly, when you look how authentication and authorization was performed, a lot of times is you sort of want to give a user particular access, for example, via VPN. And you grant this access by the concept of a certificate, like you say, okay, I grant you a certificate of the VPN CA, and we give you this certificate, and that's as soon as you authenticate against the VPN endpoint, you get access to the network. So this means just by authenticating to the VPN endpoint, you also get the authorization. And that's a model we don't want anymore. We want to really separate the aspect of authentication from the aspect of authorization.
It's yours.
Yes. Okay. So how does this architecture look like more concretely? Well, first let's look at the classical model. So you have a user, and the user wants to access a backend service. And the user authenticates these days with a username, password, two-factor, hopefully, or maybe it's in the form of a SSO ticket via cookie. So the user authenticates against the authentication point, and then the authentication point passes on the user identity to the authorization point. And there, the authorization point has a set of access control lists, and there it says, to access a particular backend service, you need to be a member of a particular user group, for example. If that's okay, you get access to the service. Now in the new model, we add the device into the mix. So we give the device a certificate, and the device authenticates against the authentication point, for example, through SSL, and we use the certificate kind of as a client certificate authentication thing. Then the authentication point can pass on the device identity to the authorization point, and here it gets interesting. So the authorization point then somehow gets access to inventory data, and then does a decision based on aspects of a machine. Like the idea is that we come up with an idea of what is a healthy device. So in the ACL, we then define, okay, if you want to access a particular service, you need to be part of a particular user group, and we also expect your device to be in a certain state or in a certain health state, if you like. Okay, so inventory is actually a really interesting problem, and it's a pretty hard one. I spent 2 years already on this topic, and when I look at the inventory landscape in an organization, you will start to figure out that you don't have the inventory to query. So there is usually a whole plethora of inventories which are canonical for particular aspects of a machine. And there are two types of inventories, if you like. So the first one are prescribed inventories. So these are inventories where for example, let's make the example of an inventory where you keep track of assets of an organization, which you sort of keep for bookkeeping inventory. So these are things which are prescribed, like somebody has manually entered this information that this device exists in the organization. On the other hand, we also have management systems which report in about the state of the device, what software has it installed, is the device encrypted, and so forth. So these are descriptive inventories. So the idea is that we somehow get hold of these two sets of inventories and somehow figure out per device the individual data pieces. Okay, so as I said, like there's not the inventory in the organization, and probably creating the unique global unified inventory is a pretty hard job, and probably you're going to fail. So we decided to take another approach, which we kind of loaned from a concept of a meta directory. So we said we are building a meta inventory. So the meta inventory's purpose is to connect to the inventory data sources upstream, collect the information, and correlate it down on a per host basis. And this meta inventory then provides the interface where the authorization point can interact with.
Okay, so after you've gotten this overview about the blueprint, we want to show you an example of an implementation that we're currently working on at Google. So on the left-hand side, you see the user authenticating via SSO and the device. presenting a certificate to the reverse proxy, which basically is the front end to all corporate services and websites. And the reverse proxy uses an ACL engine that looks up device state and user and group information in a directory service and in our meta inventory. So the reverse proxy itself does not have a lot of logic about building or granting or denying access, but that is done by an external service. And to give you some concrete but synthetic examples, let's assume there's 3 different services that you want to offer. One is a payroll system, another is a dashboard of some sorts that you have in your reception that shows some nice stats about your company, and the third would be a cafe menu. And there's various things you may require from a host displaying this data. So for example, you may want to have device authentication in every single case, just because you want to make sure that the devices displaying this data are actually owned by your organization. And the second one might be user authentication. So the payroll system usually has some other access controls of who can see what. So you need that. But a dashboard that shows public information or the cafe menu is not necessarily protected by user authentication. Then you may want to see that the device that is used to display this data is actively managed. On the payroll system, again, you want to avoid that someone has a system that is not in a good state, where this data could be stolen and exfiltrated. And you also don't want someone to mess with your dashboard display and show things you don't want them to show. And then the same is for the patch level of the machine. The easiest or simplest thing you may want to have there is a certain operating system level. And again, this might be necessary for the dashboard and the payroll, but not for the cafe menu. And then for payroll, you may also want to ensure that the device has disencrypted so that the data is protected at rest in case a laptop gets lost or stolen.
Okay, so that's the basic model, but how do you get this bootstrapped? So this is actually a pretty challenging architecture to start working on. And a particular challenge is to establish a device identity. So you need to have a way where you, in our case, be able to hand out a certificate to a device, meaning you need to set up a CA, and you also need to fix up your inventory, basically. Usually, inventory, how is it's approached in a classical organization, is more or less a data dump. Like people just dump data in it, often manually curated, and nobody really looks in detail if this data actually is correct. So when you bootstrap into this architecture, you want to link the device or the certificate to actual inventory entry to make this work. And the data quality is actually a really big problem to correct. Like when you start out with managing any type, or let's say when you start to depend on any type of inventory and you want to depend on a particular aspect which is represented in the inventory, you can expect that there will be a lot of incorrect records, missing records, and so forth. So it's pretty common when you look at this the first time that maybe 75% of the devices are correctly represented and the rest 25% of the devices are not properly represented. So you need to somehow correct this data, and correcting this data is actually really gory work to do, and it also gets wrong all the time. So you need to find a way where you can automatically gate so that the inventory starts to get corrected. And the way we approach this in our infrastructure is by using this, the certificate authority. So when we issue a certificate, we actually look into the inventory if we have any knowledge about this device and if this device is in a certain setup we want it to be before we provision a certificate to a device. Then one thing to note, however, is there is a dependency on user credentials. Like you don't want to issue a certificate carte blanche, meaning just by the device talking to the infrastructure it gives you a cert. So there's a dependency on user credentials. So you bootstrap into this with a user actually logging into a machine.
Besides the bootstrapping problems, there's also a couple workflow challenges. We are implementing this on top of the existing infrastructure with the goal of never interrupting the user's work and ideally allowing them to migrate to a workflow that is just better for them than before. And there are several things you need to look out for in particular. One of them is systems management. A lot of systems management tools still have this parameter model in mind, and you need to be connected to an enterprise network, for example, to get software updates or configuration changes. So we needed to either design our systems management tools in a way that this doesn't present a limitation anymore, or we had to wrap them in other helpers that remove the limitation for things that we couldn't change from the ground up. Another problem is all those tools that you usually use that react badly to increasing network latency. We did a lot of net flow analysis to figure out which services we can easily migrate and which ones we couldn't. An example for something that you cannot easily fix is synchronous network attached storage. So we are moving to asynchronous cloud-based storage wherever that's possible. And in other cases, we've written our own storage systems that deal better with this kind of setup. And in particular, untrusting the network is very hard when you have long tail and legacy workflows. For example, thick applications that have their own protocols to talk to their endpoints, like building management software or other proprietary software that you use to run your company.
Okay, so this sounds all good. But I think we want to give you also some advice how you can bootstrap such an architecture in your organization. And actually, the technical side of this is one thing, but actually aligning the organization to actually follow such a path, that's the other big challenge to have. So it's really important to build support in your organization for such an idea, which means you need to start talking in your IT organization about this, start doing tech talks, and it's really important that you reach all the people who are potentially targeted in your IT organization with this program. Also, very fundamental is to get support from executive layer and SVPs that they also can help drive the organization to move forward on this architecture. Then the next part is getting the data. So one aspect is certainly the inventory and how to get it right so you can provision credentials to a device. But also another aspect of it is the analysis part you need to put into the network. So Harald just mentioned net flow analysis. These are things which you need to set up to figure out what's the actual state in your corporate organization, like what workflows are there, how many machines are using these workflows, and kind of figuring out groups of use cases and then go along and figure out how you can move these groups of use cases into a more cloud-based environment. And then the architecture we presented, you can actually implement it on the web, as we have shown with the reverse proxy, but you can apply this model also to Wi-Fi access, to wired with 802.1x. But you can also, if you want, you can apply it to VPN, although VPN is certainly something we want to get rid of. But there will probably always be some legacy application out there which requires VPN.
Okay, so to wrap up, a quick comparison between the two models. So in terms of usability with the parameter model, you either are inside the organization or outside. So if you want or need to work from somewhere that's not your desk, you may need some kind of remote access solution. And in the Beyond Corp model, there shouldn't be a difference between sitting at your desk or anywhere else. It should just work. And all the controls are applied equally no matter where you come from. And the applicability of the parameter model, again, is usually only on your internal network, and it starts breaking apart when you have mobile devices that move around, or even by adding a VPN, you end up having a lot of issues that break up your nice and clean model of high walls and limited access. Whereas in Beyond Corp, since we design with access from any and all networks in mind, including the internet, that is not a problem, and we can basically just use it there as well. The parameter model bases trust on an IP address or maybe a network port. We have the device ID and state, and we look at that instead. And this is portable, and we can access it from anywhere. And we can attribute access in the parameter model only barely, as soon as you have, for example, different kinds of private networks that are bridged, which often happens if you have a VPN. You may end up having difficulties figuring out which device actually is behind a given IP address without some other acrobatics. And on the Beyond Corp model, we always look at the device, so it doesn't matter in which part of the infrastructure or access tier we look, we always know it's this user using this device currently being active. And segregation works on the perimeter only for your internal network, and in extension you have to treat remote access as some kind of internal network that isn't, and there's lots of problems because you're basically limited by VLANs, and VLAN hopping is pretty easy. So, and with Beyond Corp we can segregate not only per device but also per service, because we set the ACLs per service in our ACL engine or at the authorization point.
Yeah, you can also think of it as we are putting the security around the endpoint and the service on the server side. So you could say like we build a perimeter around the pair of this compared to this really big blob of stuff.
So, and then Cian went into this a bit, but it's worth repeating. In the parameter model, you don't have any carrot nor stick to drive inventory data quality, so it requires tons of work, which probably never leads anywhere. And in the Beyond Corp model, we have a process that drives this, where if you don't fix it, 25% of your organization could lose access because, I don't know, someone mistypes MAC addresses every single time. So that is the overview, and with that, we are ready for questions.
Yeah, as you can guess from earlier on, I'm a massive fan of this architecture.
Can you speak up, please?
Yeah, I'm a big fan of this architecture, and thank you very much. Can you tell us a little more? You mentioned a few times that connectivity could depend on the health of a device. Maybe you could tell the audience exactly what health means in that respect.
That depends on how you define it, and that's actually one of the unstated challenges, I would say, to actually define what is healthy, in which kind of state would you accept the machine to access your data and where not. And you have certain parameters. I mentioned, for example, full disk encryption for the payroll access. Users often can and will circumvent certain things we want to have enforced on machines. And right now they just go on, and then we could actually very closely take away the access that they are losing for themselves by shooting themselves in the foot.
I think it's also important to note it depends on how much you are in the process in there, because when you start with this architecture, you probably only want to enforce a few aspects which you actually want to check, because every bit of information you add to the rule of establishing healthiness, it's something you need to assess the data quality for and fix it. And so this is a process you go into, like you start small and then you build up your rules. And every time you build up, you usually go through a process where you build the rule in monitoring mode, you check how many machines would be dropped off the network, and then figure out the root causes for the breakages, fix this stuff, hopefully automatic. If not, then you need to have tech support helping out. And you drive the quality to a point where the number of potential machines which get kicked off and need remediated are so small that it is still handleable by your by your support organization. So that's how you go through the process here.
So you mentioned legacy services and so on and how you deal with them. How difficult is it, and how are you getting around situations like applications that are not under your control? I mean, if you talk about the payroll application, say, the SAP FAT client, say, or things like desktop operating systems that really want a synchronous file store for people to share files with, because that's just how they go, SMB and so on.
In some cases, we just get rid of those. And it's funny because it's true. And in other cases, this is the long tail where we keep some kind of perimeter, but because it's suddenly a limited domain that we need to watch out with limited kinds of services running on it, it's much easier to observe and make sure that everything runs the way we want, or figure out if someone does something we don't want them to do.
And of course, like if a vendor provides a web integration, then of course we would like to see the web integration deployed compared to FAT clients.
Of course. So do you do things like VPN if you have to have applications that still think I need a privileged network address?
Yes.
Okay. Even internally?
Yes, but there's a difference if you have to have tens of thousands of people use the VPN to read company email, or just 300 people for, say, payroll or financial information.
Thank you.
Yes, next one.
Hi. Hi. Neat architecture. So I was wondering, for Google's implementation of this with some of the components you had to write, which are perhaps applicable outside Google, are there any plans to open source?
Yes, so we certainly try to open source bits and pieces which go with it. So when you think about the system management aspects which you need to somehow plug to the outside in a sane way, that's where we have already started. So maybe you want to attend tomorrow's talk of Greg Castle about Mac security, and Clay Cavines and Ed Eigerman's talk about how to manage a big Mac fleet. There you will learn a lot what tools we use to actually make that possible. So we have actually open sourced a software package management infrastructure called Cian. So other peoples could actually use it to manage their Macintosh fleet from wherever on the internet.
So one of the parameters of health that I would consider is, has this device that's about to sign on to the payroll server, has this device been rooted? Is it busy, does it have a rootkit running that can exfiltrate data? How do you answer questions like that?
So when you look about the architecture here, this is very much focused to limit the access of a device. Like, we want to limit how much a device actually gets access into our infrastructure. And the hardening aspect is something different, like how do you make your machine secure? And again, like if you want to see example how this is done, I really recommend to see Greg's talk tomorrow on Mac security. Next one, please.
How do you manage to handle client certificates in a secure way on devices that not have TPM chips? That's
a very good question. So the ideal situation would be that you can back a certificate with TPM, but we figured out that TPM is actually really hard. So for several reasons at the moment. So some devices don't have a TPM. Think about Mac computers, they don't have a TPM. Another aspect is middleware, and in particular also stability of the middleware. We have seen lots of stability problems in some middleware stacks, and they are so bad that it's actually not really supportable by your support organization. This is kind of still a challenging problem, but we are trying to improve that as we go. Yeah.
And in a way, it's again part of the hardening question more than of this architecture, but we have teams working on that.
Hello. I'm just a little confused at how the architecture actually works. Are you proposing that when you're removing the perimeter, that then everything in your network, all the objects are exposed, and that exposure is controlled somehow through access controls, through some mechanism?
Yes. It is very much a change in philosophy. We have the reverse proxy as one example, where everything that wants to go to our services has to pass through that proxy, and that proxy is enforcing all the rules we want enforced. And that is true whether you're on the internet or on a corporate network, which of course in our offices still physically exists.
And the other aspect of it is making your corporate network untrusted. Like, you really try to move your devices into another segment of the network where they don't have any privileged access anymore to whatever core you still have. Like, there will always be a little core of stuff which is still higher privileged, and but we want to limit the access to this core only to the particular devices where we want to have on, and all the rest should kind of move through things like the reverse proxy, and that's how we control the access.
So for those items or for objects that you expose, I don't see how you're addressing things like DDoS attacks and things like that.
That's not part of this infrastructure, but we have something at Google to deal with that separately.
My question is regarding the different types of clients that you support and the different management techniques. So if you're supporting, say Mac, Windows, and Linux, are you utilizing different management techniques for each one, say for certificates or health checks, or are you trying to aggregate all of them into one system for health checks and certificate management and things like that?
Yes to both. So historically, there's many different tools, some of which you will, again, for the Mac platform, be able to hear about in tomorrow's talks. Some of them we build ourselves, some of those we open sourced, some others are industry-wide standards that people use, for example, on Windows. And the meta inventory is kind of unifying this data we get from these various tools, but also where possible we try to merge on the client level, but it's not always possible for various reasons, or simply because we want to get stuff done and not just get the perfect solution.
Thank you.
All your examples involved clients. Were you anticipating thinking about your servers in this way?
Yes, this is certainly something we think about, but the focus in particular in the moment is the client aspects of it, because there are a lot of clients out there and they're exposed every day to the roughness of the wild.
Yeah, servers have less of an opportunity to move inside and outside the perimeter, so they're not as exposed as the clients that we have standing around here, for example.
Just wondering if you guys heard of SQRL. I think it's a protocol that was developed by, or proposed by Steve Gibson, and it dealt about device authentication and...
Can you say again?
SQRL.
I've heard of it.
That doesn't ring a bell.
Weigh in on what your thoughts about that are?
That's not our pedigree, I would say. We're the wrong people to ask about that.
Thanks.
All right. Well, thanks very much for your attention. And if you have any questions, we'll be available outside the room.